Welcome back to the Dargslan series, Part 10, where we stop guessing and start measuring. In this session, we're tackling CPU versus GPU benchmarks for local LLMs, and the goal is simple: real tokens per second numbers from your machine, not marketing claims from someone else's. We'll build a small, reproducible benchmark against the API, and by the end, you'll know exactly what your hardware can do. Before we benchmark anything, let's agree on what's worth measuring. Three numbers really matter here. Tokens per second, the eval rate, is your headline. Above 20 feels snappy, below 5 feels painful. Time to first token captures the latency before generation even starts, which is what makes or breaks chat feel. And total request time is the honest one. Wall clock from enter key to final token, the number your user actually waits through. Here's the good news. You don't need any extra tooling to get those numbers. Just hit Ollama's generate endpoint with stream set to false, and the response hands you everything on a plate. You get total duration, load duration, prompt and eval counts, and the eval duration for generation itself, all in nanoseconds. Divide eval count by eval duration, and you've got your tokens per second straight from the source. So let's turn those raw nanoseconds into something meaningful. Three quick formulas do the job. Eval count divided by eval duration in seconds gives you the headline tokens per second number. Add load duration to prompt eval duration, convert to seconds, and that's your time to first token. How long before the model actually starts talking? And total duration over 189 is just the wall clock time, end to end. Three numbers, one request. Now let's wrap those formulas into a tiny Python script. About 30 lines saved as benchmark.py. We fix the prompt so every run is comparable, default to Llama 3.1-8b, but accept a model name on the command line, and plan for 5 runs to smooth out noise. The one-run function just posts to the local Ollama endpoint, parses the JSON, and returns those 3 metrics we just defined: eval rate, TTFT, and total time. Before we trust any of those numbers, there's one gotcha to handle. The very first call has to load the model weights into memory, so it's always misleadingly slow. The fix is a warm-up run that we throw away, then a loop of real runs we actually keep. We print each run's eval rate as it goes, then report the median across all 5. Medians shrug off the occasional outlier far better than a mean would. Here's what that actually looks like on a real box. Run 1 comes in at 47.3 tokens per second. That's the cold load tax, and then runs 2 through 5 settle into a tight band around 51. The median lands at 50.9, and because we're using the median, that slow first run gets quietly ignored instead of dragging the whole average down. That's your steady state number for this model on this machine. Now zoom out and apply that same methodology across a range of hardware, all running Llama 3.18b at Q4. An old DDR4 laptop crawls at 3 to 6 tokens a second, genuinely painful, drop to a 3B model. A modern laptop CPU is usable for short prompts. Apple Silicon really shines here. An M2 hits 25 to 35, smooth enough for chat. On the GPU side, a humble RTX 3060 already matches an M3 Max at 45 to 60, and a 4090 pushes past 120, at which point you're wasting silicon on 8B and should jump to 70B. With those numbers in hand, you need a way to read them sanely. 4 quick rules. Anything above 20 tokens per second feels comfortable for chat. Past 50, it's basically instant, and 100 plus is faster than you can read. Always discard run 1. That's just weights loading into RAM or VRAM. Watch the spread between runs. Wild swings means something else on your box is fighting for resources. And keep NVIDIA SMI open. If the GPU is idle, your model silently fell back to CPU, which Ollama PS will confirm under the processor field. Now that you can read the numbers, let's put them to work across models. Wrap the same benchmark in a shell loop over every model you're considering. Here, Llama 3.2, Phi 3.5, the 8B Llama, Mistral, and Quen, and let it run. On a 3060 with 12 gigs, the 3B Llama screams at 118 tokens per second, while the 7 and 8B class settle around 50. That spread is your decision matrix. Pick the smallest model that's still smart enough for your actual job. Now hold the model fixed and swap the hardware. Same Llama 3.18b at Q4, same prompt. A modern laptop on DDR5 pushes about 10 tokens per second with a 1.8 second time to first token, while a used RTX 3060 with 12 gigs of VRAM hits 51 tokens per second and answers in 0.3. That's roughly 5 times faster, and it's almost entirely a memory bandwidth story. GDDR6 simply feeds the weights faster than system RAM can. For around $280 used, that's the single biggest quality of life upgrade you can make. Before you trust any of those numbers, watch out for a handful of traps that quietly poison benchmarks. Always discard the first run. It includes model loading and skews your average by a second or two. Keep the prompt string fixed across models, close the browser and chat apps so nothing else is fighting for GPU or RAM, and never report a single run. 5 iterations and a median is the bare minimum. And label your quantizations. Q44KM and Q80 of the same model are effectively different beasts. Now speed is only one axis. A model that cranks out 80 tokens per second but gets the answer wrong is useless. So rerun your 10 real daily prompts and score them correct, partial, or wrong. Then stress the dimensions that actually break things in production. Push 4K, 16K, and 32K context to find where throughput collapses. Fire 5 parallel requests to see if the server shares fairly or serializes. And keep an eye on Ollama API. Once you spill into swap, the benchmark is over. So let's pull the threads together. Stop guessing and measure your own box. 30 lines of script against the API, 5 runs, and you've got numbers no generic benchmark can give you. Eval rate is your headline, but always warm up first and take the median. Throw away that cold start call. Expect GPUs to land 5 to 10 times ahead of CPU on bandwidth-bound work, 10 tokens per second on a laptop, 50 on a 3060, around 150 on a 4090. And never forget, the fastest model that's still good enough is the right one. Speed without quality is just noise. And here's the page worth printing. 12 fields, formulas, and rules on one sheet. The left column is the JSON you'll pull from the API, eval count and eval duration. Give you your tokens per second once you divide by 1e9 to get seconds. The right column is the discipline. Warm up, fix your prompt, take the median of 5+ runs, and use Ollama API to confirm you're actually on the GPU. 20 tokens per second is your comfort line for chat. Tape it to the wall. And that closes phase 2. You've got your hardware mapped, your models picked, and real tokens per second numbers from your own machine. No more guessing. Phase 3 is where it gets interesting. Embeddings, vector search, and retrieval augmented generation, so your local AI can actually read your documents. Pull nomic embed text, and I'll see you in part 11.